Good morning, fellow physicists. Welcome to week 2. You've survived week 1, and I'm out here irrigating my pastures. I thought this was a good opportunity to introduce what we're going to be learning about this week. So this past week, you learned about Newton's laws, and just to recap those real quick, Newton's first law says that an object in motion stays at motion unless acted on by another force. Newton's second law allows us to calculate the magnitude of that force given the acceleration of an object. And it really is the definition of what we call mass, which is that stuff that responds to being pushed or pulled by a force. And then Newton's third law is the equal and opposite force law, which says that every time there's a force acting on you, there's an equal and opposite force acting in opposition to that force. And so I came out here today to talk a little bit about what we're going to be learning this week, which is conservation of energy, potential energy, and kinetic energy. And it's another way of thinking about forces. Energy is a property that stuff has, and it can transform from one type of energy to another. And I'm always thinking about that when I'm irrigating my fields, because we've got water at a high elevation, and that gives it potential energy, and then it flows to a lower elevation, giving it kinetic energy and causing us, allowing us to have the water flow out to irrigate our pastures. So here you can see the result of that. We've got a ton of water out here today, and that's the result of this transfer of potential energy into kinetic energy. And in fact, if you come over here, you can see here's the water flowing right here, a direct result of that conversion of potential energy into kinetic energy. And of course, we can use that here to irrigate our fields. Now for your activity this week, you're going to look at this conversion of potential to kinetic energy by looking at the swinging of a pendulum. So you're going to construct a pendulum, which is basically just a heavy weight on a string, and you're going to see what happens when you raise that string to different levels of potential energy and let it go. And you're going to measure that by measuring how long it takes the pendulum to swing back and forth along that path. And you should see that as you give something more potential energy, that it will have more kinetic energy at the bottom of its arc than it did at positions of lower potential energy. So that's your activity for this week. And in your reading and your videos, you're going to be learning about conservation of energy, conservation of momentum, which you'll learn about in your reading. And we'll have a Fermi problem on Monday about the energy that we use and how that energy is growing. And you can see there's Miss Maya over there digging for mice as we flood out the pastures here. So that's our plan for this week. I'm looking forward to hearing from you, and if you've got questions or comments, feel free to contact me, and we'll see you this week.